Okay, so here we are. We are asked to find DeMoivres theorem. And if you look in your formula booklet, which is right here, here is DeMoivres theorem here. And I'm going to cut and paste it. It's right there in your formula booklet, so you know where it is. And I'm going to put it right here. There is DeMoivres theorem. At this point, you only know this and this form. This is coming shortly. But what DeMoivres theorem says is if I take z, some complex number to the power n, which is what is here, this exponent applies here, and it goes to the angle, gets added to the angles as well. So that's what this is saying here. And so I want to use DeMoivres theorem to find 1 plus I to the power 6. So the first thing I'm going to do, I'm going to put it to polar form. So r, I can quickly see, is going to be root 2, because it's 1 plus 1 square root. And cis, well, if I think tangent theta is equal to 1 divided by 1, theta is equal to pi by 4. Think about my quadrant. I go x is plus 1, up 1. I'm in the first quadrant, so pi by 4 is excellent. So this is equal to z, if I call this z. Now, if I want to take z and raise it to the power 6, then I'm going to take root 2 cis pi by 4 to the power of 6, which is root 2, using DeMoivres theorem, I raise r to the power n, so root 2 to the power 6, cis, and I multiply my angle times n, so it's 6 pi over 4. Taking that, I know that this is 2 to the 1/2 times 6, cis 3 pi by 2, which is 2 to the power 3, which is 8. Cosine 3 pi by 2 plus 8I sine 3 pi by 2. Well, I could just say this is 8 cis 3 pi by 2. But if I expand this out, which is optional, I know that the cosine of 3 pi by 2 is 0. The sine of 3 pi by 2 is -1. And so I know this ends up being negative 8I, because this equals -1 and this equals 0. And so this is z to the power of 6. And if I use, it says check using your GDC. Well, one of the cool things is our calculators do a lot of these polar operations. So I'm going to check to make sure my mode is good and it's a plus bi. And so I'm just going to go 1 plus I to the power of 6, and I indeed get -8I. Okay, so here we're going to simplify this expression here, and I can use this one here. It means I'm going to have to use DeMoivres theorem. And when I use DeMoivres theorem on the first part, there's r is 1, so 1 to the power 6 is 1. But I end up multiplying 6 times 6. So this is cosine 36a plus I, oh my goodness, plus I sine 36a times cosine 3a plus I sine 3a over cos 4a plus I sine 4a. And so now I use the operations of multiplication. When I multiply these two, I end up adding these exponents. And then when I divide, I end up subtracting the 4. So putting it all together, I end up with cis 36 plus 3 is 39. minus 4. So 36 minus 3, or plus 3 minus 4 is equal to 35. And so it ends up being cis 35a. That is simplified.